Today we're going to look at measuring angles. There are two types of angles that we use for measure: degree measures and radian measures. Degree measures might be a little bit more familiar. It's the angle formed by rotating the initial side exactly once counterclockwise until it coincides with itself, otherwise known as one revolution, is measured 360 degrees. 1 degree is 1/360th of a revolution. So if you rotate exactly one time, that's one revolution, which is 360 degrees. If the radius of a circle is r and the length of the arc intercepted by the central angle is also r, then the measure of the angle is 1 radian. So if you go 1 radius around a circle, the angle that you get from that is 1 radian. We'll take a closer look at that in the next slide. So here we have a circle, and as you can see, it's cut up into 6 parts, and you have one little section left over after that. Each one of these colors along the circumference represents the length of 1 radius. These 6 equal parts are each 1 radian, and that little part that's left over is a part of a radian. Let's see why. So there's 6 whole radians and a little more than a quarter of a radian in a circle, 6.28. The length of each arc with an angle of 1 radian is equal to the length of the radius of the circle. So one circle, if you think of the length around the entire circle with radius 1, will be equal to 2 pi, which is where we get the 6.28 from. So if we're looking at it in terms of degrees, a full circle is 360 degrees. 1 radian, if you cut that up into 2 pi pieces, is 57.29 degrees. Here we can see again, if you rotate 1 radian, the radius will be equal to the length of that arc. So we're used to cutting up circles in degrees. 1 rev is 360. If you take a quarter of a revolution, you take a quarter of 360, that's 90 degrees. If you take half of a revolution, that's half of 360, which is 180. We should already kind of have an understanding of this. We're going to do the same. So if 360 degrees is 2 pi radians, if you cut that in half, you get pi radians. If you cut that in half, you get pi over 2 radians. This is the way we express radians for common angles in a circle, as fractions of pi. So a quarter of a circle is pi over 2, half a circle is pi, the full circle is 2 pi. So let's see how we convert degrees to radians. Now if you have any random degree amount and you want to convert to radians, first thing I'm going to do is draw a little T-chart, straight across and straight down. The line going across represents a fractional line, so anything at the bottom is dividing, and that vertical line is representing multiplying. So the first thing I'm going to do is I'm going to divide by 360. The reason why I'm doing this is because I want to get rid of the degrees. Now a full circle in degrees is 360, so that's why it's 360 degrees. It's at the bottom because you're trying to get rid of degrees. At the top, I'm going to put what I'm converting to. I'm converting to radians. So a full circle in radians is 2 pi. So my conversion factor is 2 pi over 360. Let's do this example with 60 degrees, for example. If I had 60 degrees there, all I would have to do is multiply straight across. And I end up with 120 pi over 360. Now if I reduce this fraction, 120 over 360, 120 goes into 120 one time and goes into 360 3 times. So that gives me 1/3 pi, or you could just say pi over 3. Now let's take a look at this the other way around. If I have pi over 3 and I want to convert it to degrees, well, I obviously already know that it's going to be 60 degrees, but I want to see how we get that. So when I write my fraction, I'm going to extend that fraction line. I'm going to draw my vertical line. Now this time at the bottom, we're going to have 2 pi because we're trying to get rid of radians. And at the top, we're going to have 360 degrees because we're converting to degrees. Now again, we are using full circles. The 2 pi is a full circle in radians, and the 360 is a full circle in degrees. We multiply straight across, and we end up with 360 divided by 6, which simplifies to 60. Let's do another example. Here we have negative 54 degrees, so I'm going to set up my little T-chart. I'm going to put 360 at the bottom and 2 pi up top. The degree units cancel, and then we multiply straight across. So then we try to reduce this. We get 3 over 10. So my answer is negative 3 pi over 10. Here we have another example, negative 11 pi over 18. So let's go ahead and extend the fraction line, put our multiplying line. At the bottom this time we'll have 2 pi because we're getting rid of radians. So we put a full circle in radians at the bottom. And up top we have 360, a full circle in degrees. Now we're going to cancel out what we can and multiply straight across. We end up with 3,960 over 36. Over 36. We simplify this and we get 110. So that's a negative 110 degrees. You notice the negative sign doesn't really do anything, you just leave it there. Now we've done coterminal angles previously. We're going to take a look at coterminal angles for radians. So in this question we want to find one positive and one negative angle that is coterminal with the angle pi over 3 in standard position. So remember when we did adding and subtracting 360 to get coterminal angles? Well, we're basically going to do the same thing, except we're adding and subtracting 2 pi. We're still adding and subtracting a full circle, only now we're doing it in radians. So pi over 3 plus 2 pi. Let's go ahead and make this a fraction so we can add it. We need a common denominator, so we need to multiply the top and the bottom by 3. And this gives me pi over 3 plus 6 pi over 3. Now because we're going to add by 2 pi a lot, I just want to highlight the fact that when we add, we're going to be adding by double the denominator basically, because we're always going to be multiplying 2 pi by whatever the denominator is. So we're adding 2 pi to pi over 3. If you double the denominator, that's 6. So pi plus 6 pi gives me 7 pi, and it's over 3. We're going to do the same thing with subtracting. Now when I make it a fraction and multiply the top and the bottom by the denominator, I end up doubling the denominator again. It's going to be pi over 3 minus 6 pi over 3. 1 minus 6 is negative 5, so we have negative 5 pi over 3. This time we're going to do it using 7 pi over 5. So to get my positive coterminal angle, I'm going to add 2 pi. If I double the denominator, that's 10 pi over 5. So let's see how this works out. Make it a fraction, multiply the top and the bottom by 5. plus 10 pi over 5. So that's 17 pi over 5. To get my negative coterminal angle, I'm going to do the same thing but subtract. So 7 minus 10 is going to end up being negative 3 pi over 5. All right, hopefully that explains it for you guys. Let me know if you have any questions.